Hello everyone, welcome to Mathos Bridge. We train and learn. Today, we shall continue our exploration in object-oriented programming fundamentals. Let's get started. In today's agenda, we shall explore inheritance concepts. What is meant by inheritance? Inheritance is one of the pillars of object-oriented programming. Inheritance allows us to define a class in terms of another class. In other words, it enables one class to acquire attributes and methods of other class. A child inherits some properties from parents. Similarly, a parent inherits some properties from grandparent. If you look at this example, parent can inherit some properties from grandparent. On the other hand, a child can also inherit some properties from parent. This feature provides an opportunity to reuse the code reusability. Inheritance implements the easier relationship. For example, car is a vehicle, pet is an animal, dog is an animal, pet is a dog, right? Base class, the class whose properties are inherited by the subclass, is known as a base class. We also call it as a superclass. A top level class is a superclass or the base class. On the other hand, the class that inherits properties from superclass is known as subclass. We also call it as a derived class. Base class is always a top class. All the classes which derives from base class are known as a derived class. Let's look at concept of class hierarchy. In an object-oriented programming, classes are organized into superclasses and subclasses. Superclass means base class, subclass means derived class. At the top of the class hierarchy are most general classes, and at the bottom classes are the most specific classes. A subclass inherits all the properties such as attributes and methods known as functions defined in its superclass. All the attributes and methods of a superclass can be inherited into a subclass. A class may simultaneously be the subclass to some classes and superclass to another classes. If you look at this diagram, car class act like a derived class to top class, vehicle class. Car is a vehicle. If you look at another hand, Kia is a car, right? Is a relationship. Kia inherited from car class. So with respect to Kia, a car is a base class. With respect to vehicle, car is a derived class. This is a concept of class hierarchy. Types of inheritance. We have single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. In a single inheritance, we have one parent and one child. In multiple inheritance, we have two parents, one child. In multi-level inheritance, grandparent, parent, and a child. In hierarchical inheritance, we have one parent and multiple children, like a multiple derived classes. In hybrid inheritance, we have a combination of one or more other type of inheritance. If you look at single inheritance, we have a base class, we have a derived class, right? A single inheritance where subclass inherit the properties from superclass, one parent, one child. Let's close look at this diagram. We have a parent class has two attributes, age and name, and we have a child class which inherits from parent class, meaning we acquire some properties from parent class. Let's suppose we are trying to acquire age and name from parent class into child class. So how would you see now? After inheritance, we can see child class has three attributes: age, name, course free. Before inheritance, we have one attribute. After inheritance, we have three attributes, combination of parent and child. Let's take a look at this example, which explains concept of single inheritance programmatically. Here we have a parent class, we have a child class. Child class inherited from parent class. In child class, we have one attribute. In parent class, we have two attributes. Through a single inheritance concept, child class inherited some of the properties from parent class, meaning here the two attributes of parent class are getting inherited into child class. Let's see in main program. In main, we created instance of child class and we initialize the values to the three attributes of child class, and then we try print them. If you look at this output, we were able to set the values in the initialization phase, and then we are trying to access them from outside of the class because all three attributes are defined under public access specifier, so we can access them from anywhere, right? This is a good concept of single inheritance. In multiple inheritance, a derived class can have more than one base class, a superclass, which inherits properties from all superclasses. We have a two parent class, one child class. A child class can inherit the properties from two parent class. This is an example of multiple inheritance. In multi-level inheritance, a subclass is inherited from another subclass. We have a base class, derived class 1, derived class 2. So derived class 2 is inherited from derived class 1. A class is derived from another derived class. So a grandparent and a parent and a child can form a multi-level inheritance. Let's look at hierarchical inheritance. In hierarchical inheritance, we have one superclass known as a base class, and we have multiple derived classes which are derived from one superclass. We have a parent class, we have a child classes. Derived class 1, 2, 3 are known as the child classes. In hybrid inheritance, we use combination of two or more types of inheritance. We can use a single inheritance, we can use multiple inheritance and multi-level inheritance. In this example, if you look at one parent class and then two derived classes in the middle. Derived class 1 and 2 are derived from one single parent class. On the other hand, derived class 3, which is inherited from derived class 1 and derived class 2. So example, parent class is a superclass, middle classes are the derived classes 1 and 2, and then third class is the derived class 3, right? Which is a, kind of a subclass to derived class 1 and 2. Here is a consolidation of all types of inheritance at single shot. Single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. Let's look at this example. We have an automotive, we have two-wheeler, three-wheeler, four-wheeler are the derived classes which are derived from base class, superclass. We have a scooter and motorcycle are derived from two-wheeler. Scooter is a two-wheeler, motorcycle is a two-wheeler. Similarly, bus and car are derived from four-wheeler class. Bus is a four-wheeler, car is a four-wheeler, is a relationship. So if we look at closely, automotive, two-wheeler and scooter forms a multi-level inheritance. Automotive and then three-wheeler forms a single inheritance. And here is a hierarchical. 1 superclass, 3 subclasses is known as hierarchical inheritance. Let's look at another similar inheritance example. We have a base class called bird. Flying bird, non-flying bird are subclasses to the bird class. Similarly, we have a specific classes of flying bird. We have a specific classes for non-flying bird. This is another similar example for combinational inheritance within it. Here we will see how access specifiers works in the concept of inheritance. Let's say we have a base class, we have a derived class. Derived class inherited from base class, meaning the properties of base class can be inherited into child class one way or other, right? We know we have a access specifiers like a public, protected and a private, isn't it? If you inherited base class as a public class, what that mean, all the properties of parent class can be inherited as is into child except a private. Private access specifiers are cannot inherited into derived class by definition, right? So public can be a public in derived class, protected can be protected in derived class. If you inherited parent class as a protected, in this case, all the public properties of base class will become protected in derived class. All the protected of base class will be remains protected in derived class. If you inherited parent class as a private, when we create a child class, then all the properties of base class, when I say all, both public and protected will become a private access specifiers in child class. This is very important concept. which helps while building a inheritance classes. Advantage of inheritance. Inheritance allows you to create new classes from existing classes. Reuse of code is one of the primary benefit of inheritance. Can avoid duplication, promoting a faster development time, known as a code reusability. On the other hand, inherited classes can be treated as a instances of their base class. This feature enables you to write more generic and flexible code that can work with various derived classes without knowing a specific types. We also know this feature as a polymorphism. It enables you to create a hierarchical classes that model real-world relationships. Inheritance helps organize the classes hierarchically, making the code base more structured and easy to manage. Changes made to the base class automatically propagated to the derived classes. It reduces the risk of errors and simplifying maintenance of source code.
Thanks for watching. Please like, share, subscribe, click on the bell icon, and please leave the comment. Happy learning. Thank you. Stay tuned to the upcoming sessions.